Hello everyone, welcome to 1045 Engineering. We are here with yet another video in our Grind 75, a Better Blind 75 coding series. So today's problem is on insert interval. Let's jump into the problem statement, understand it and start solving. Okay, last time we had solved maximum subarray, we'll mark it checked. Let's start with insert interval. Okay, so let's go through the problem statement. You are given an array of non-overlapping intervals, okay, where interval I is start I and I represent the start and the end of ith interval, and intervals is sorted in ascending order by start I. Okay, you're also given an new interval start end that represents the start and or end of another interval. Insert this new interval into intervals such that intervals is still sorted in ascending order by start and intervals still does not have any overlapping intervals. So we need to merge overlapping intervals if necessary. Return intervals after the insertion. Okay. So before we start solving, let's understand the problem from the examples. Okay. We are given these intervals 1, 3, 6, 9. So intervals means something that is starting at 1, ending at 3. Then something which is starting at 6, ending at 9. Now we are given a new interval which starts at 2 and ends at 5. The resultant should only have distinct intervals, right? There should be no overlapping intervals. So 1 to 3 is actually overlapping with 2 to 5, right? We need to add 2 to 5 to this list. So we'll merge them. So 1 to 3, 2 to 5 will become 1 to 5. So it will become 1 to 5. And the rest of the intervals will be copied directly. 6 to 9 will come here. And this will be our resultant intervals. Right? Let's understand this through code example. What is going to be our approach? Let's take one example. We'll take this. Let's give it one more. We'll call it 12 to 15. 12 to 15. Okay. And let's say we are given new interval as instead of 2 to 5, I'll say 7 to 10. Okay. So this is our original list of intervals and this is our new interval. We have to do three things in all of this. First is we'll take all the intervals from the list which where the end time is smaller than the start time of the new interval, because those intervals will not be affected by our new interval. So 1 to 3 is not affected by 7 to 10, right? So we'll copy 1 to 3 to the final result answer. We'll say result. Okay, 1 2 3. Then we'll merge all the intervals that get affected. So 6 to 9 and 7 to 10, there is an overlap. So we'll merge these intervals. That will be our second operation. Okay, and we'll copy the resultant. So how do we copy the resultant in a merge? Smallest of the start time, which is 6, and biggest or the largest of the end time, which is 10 in this case. Between 9 and 10, 10 is the largest, right? When this is done, then all the rest of the intervals from the list which were not affected by the merge will simply be copied. So we can say 12, 15. That's it. This is going to be our approach, and we are just going to put this into an algorithm. Okay. One more thing to notice here is, in this one, if you notice in this example, the given intervals is 1, 2, 3, 5, 6, 7, 8, 10, 12, 16. New interval is 4, 8. Okay. Let's take this. And when we try to merge, new interval is 4, 8. When we try to merge, in the result, let's write result is equal to 1 3. This will be copied as it is. 1 2. 1 2 will be copied as it is, since the end time is smaller than the start time of new interval. Then we have 3 5. 3 5 is overlapping with 4 8, right? So after making the change 3 5 and 4 8, this becomes start from 3 and set 8, right? We merge 3 5 with 4 8. But then this 3 8, the final answer, is overlapping with this one 6 7. So we'll merge 6 7 into 3 8. 6 7 is already contained inside 3 to 8, so this will get removed. Then we have 8 to 10. Again there is a overlap between 3 to 8 and 8 to 10, so we'll merge these two as well, so it will become 3 to 10. Then 12 to 16 are not affected, we'll keep 12 to 16. Okay, so each time after the merge we have to recursively check it with the next elements as well, if the new merge is not affecting the other intervals. But the algorithm is going to be same. There are three operations. First, to check all the elements that have n times smaller than the new interval start time. Then we perform all the elements that needs merging, and then we copy rest of the intervals from the list, right? Okay. Let's start coding. So first we'll create a separate list, because we have to perform our operation several times, and then we'll copy the answer in the form of array again. Create a list to store the result. Okay, so we'll say list of type integer array, result is equal to new array list. Okay, now first operation, add intervals to the result list where n time is less than new intervals start time, right? New intervals start time. So we'll say int I is equal to 0 while I is less than intervals dot length, because we are traversing through the intervals, and intervals, so this is from the original, this one, intervals of I1 is less than new interval 0, right? So we are comparing the end time, this one, the end time from the original list intervals is smaller than the start time of new interval here, right? So wherever this happens, we simply copy them to the result list. Result dot add intervals of I, right? And then I plus plus. Now second operation, we'll perform the merge of the overlapping intervals. So merge overlapping intervals with new interval, right? So we'll say while I is less than interval start length, and so we have kept the I common, so I already reached this second stage, or in this form 6 9. So now 1 and 3 were already copied into the result. Now I has reached the second set of elements, that's 6 9. We'll say I less than intervals dot length, and now we'll start comparing intervals. So this is the original one, I 0 start time is less than equal to new interval 1 end time, because that is where the overlapping is happening. Now we'll merge them into one where the new interval will have a start time which is smaller of the two and end time which is bigger of the two, right, as we discussed. So we'll say new interval 0, that is start time will be math.max, no, we need minimum for start time, math.min of intervals I0, that is start time, and new interval 0, that is start time, and new interval 1. Now we'll update the end time as math.max of intervals I1, so that is end time, and new interval 1, that is end time, right? So we'll merge them to form a new interval which will have the smallest of the two as their start time and biggest of the two as their end time, I plus plus. And this will keep happening, right? Once we add it to the list, that will become our new interval. So as in this case we saw, right, when we merge 3 and 5 with 4 and 8, 3 to 8 becomes a new interval, and then new interval gets checked with against 6 7, then it remains 3 and 8, then new interval gets checked against 8 and 10, then it becomes 3 to 10, the new interval gets checked again 12 to 16. Now this is where it will fail and will perform the next line of operation. So in the end there are going to be 3 operations, right? So now we found the new interval. After performing all the merge, we'll add it to the list. So add the merged interval to the result list. Result dot add new interval, right? Now we'll add the remaining elements. So in the end there are 3 operations, right? First, add all the initial elements, perform the merge and add, and then add the rest of the elements. So add the remaining intervals to the result list. So it will be while I is already moving as our pointer, I is less than intervals dot length result dot add intervals of I. Okay, and I plus plus. Once it's done, our solution is in format of list and we need to return as a 2D array. So we'll just convert the list to a 2D array and return. Okay, so we'll say return result dot to array, okay, new int, and we'll pass result dot size here, and it is 2D. Okay, I hope the problem statement was understandable by everyone, and so was the solution. The only there are few hiccups, let me resolve them. Line number 8, intervalslength. I think this is becoming a common mistake now. Okay, let's submit and check. Beats 99.36. Okay, great, right? So main thing to remember in this problem statement is we have to solve it in 3 parts. First, add all the elements whichever end time smaller than the new interval start time. Then create the merge overlapping interval, add it to the list, and then add all the remaining elements or the intervals to the list, and then simply return. Okay, and this problem statement overall, if you see, is solved in time complexity of O of n, because we are reaching each set of element only once. That is all from today's video. Thank you everyone. If you have anything, please let me know in the comment section, and please, in order to support the channel, please like, share and subscribe. Thank you.